Have you ever wondered what powers your phone? Or what makes a nail get all rusty? Or even how you digest your lunch? Well, it's all thanks to this tiny, invisible dance of particles. It's called a redox reaction. And trust me, once you see how it works, you are going to start seeing it absolutely everywhere.
Okay, so let's start with a little riddle. What do a battery, a rusty old nail, and the actual cells inside your body all have in common? I know, it sounds like a trick question, right? But the answer is a single, incredibly powerful process that connects all of them.
And here's the secret. It's all about electrons. A constant, tiny exchange of these little charged particles is the engine that's driving everything, from the gadgets in our hands to our own biology. And this electron shuffle? It has a pretty cool name.
Ready to peek behind the curtain? This whole electron dance is officially called a redox reaction. And the name itself is a big clue, because it hints at the two key players in this chemical tango.
So here's the deal with a redox reaction. You've always got a giver and a taker. One substance, the donor, gives away its electrons, and the other one, the acceptor, is right there to scoop them up. It's a simple little handoff, but oh boy does it change everything.
Now here is the absolute golden rule. This is a two-way street. You cannot have a giver without a taker. These two actions are totally locked together, happening at the exact same moment. They are quite literally two sides of the same chemical coin. One can't happen without the other.
So, who are these two players we keep talking about? Well, let's meet our main characters, oxidation and reduction. If you get to know these two, you'll unlock the entire mystery of redox.
Okay, check this out. On one side, you've got oxidation. This is when a substance loses electrons. And since electrons are negative, losing that negativity actually makes the substance more positive. Kind of weird, right? On the other side is reduction. This is the gain of an electron, which, you guessed it, makes the substance more negative.
All right, I know what you're thinking. How in the world am I going to remember all of this? Don't worry, chemists have a secret weapon for this. You just have to remember one simple phrase. Leo the lion says, "Jur."
Let's just unpack that really quick. LEO, loss of electrons, is oxidation. And GER, gain of electrons, is reduction. See? Simple, right? That one little phrase is your key to mastering redox reactions.
Okay, enough with the theory. Let's see this thing in action. We're going to go on a little chemical safari and spot Leo and Jur out in their natural habitat.
So here is our case study for today. We've got an iron ion and a cerium ion, and they're about to react. Now, pay really close attention to their charges, those little numbers up top, because something is about to change in a big way. Okay, let's look at the iron first. You can see it goes from a +2 charge to a +3 charge. So, to get more positive, it had to have lost a negative electron. And what do we call that? Leo! Loss of electrons is oxidation. Boom! Our iron just got oxidized. Now, what about the cerium? It goes from +4 down to +3. Its positive charge went down, which means it must have gained a negative electron. And that, my friends, is our good old buddy Gur. Gain of electrons is reduction. So the cerium was reduced. See? It's a perfect little partnership.
So, we know what happened. But here comes the plot twist. Who was the real mastermind behind this little electron heist? This is where we meet the agents of redox. Now, it's a little bit of a mind bender, but stick with me here.
So, in our little drama, who's the oxidizing agent and who's the reducing agent? Go on, take a guess. I'll give you a hint. It might not be what you think. Okay, so here's the trick. An agent's name describes what it does to the other guy. So the oxidizing agent is the one that causes oxidation by taking electrons. And if it's taking electrons, it's actually getting reduced itself. It's the exact same deal for the reducing agent. It causes reduction by giving away its electrons, which means it's the one that gets oxidized. Mind blown.
Let's go back to our reaction. The cerium took an electron from the iron, which caused the iron to be oxidized. So that makes cerium the oxidizing agent. And the iron gave an electron to cerium, causing cerium to be reduced, which makes iron the reducing agent. See, it all makes sense once you know the trick.
All right, we have been on quite the journey, so let's take a second, recap the highlights, and make sure you've got the key rules of redox down cold. Here it is, your redox cheat sheet. Oxidation is losing electrons. Reduction is gaining electrons. Remember, they always happen together. The one that gets oxidized is the reducing agent, and the one that gets reduced is the oxidizing agent. Simple as that.
So why is all this so important? Well, in a lab, chemists use these rules to make super precise measurements. For instance, they can calculate something called equivalent weight. It's a calculation that helps them understand exactly how substances are going to react. And that's a powerful tool that helps create everything from new medicines to much better batteries.
So, we've come full circle. From the phone in your pocket to the food on your plate, our world is powered by this amazing little electron dance. So next time you see a rusty nail or an apple turning brown, you can smile and say, "Ah, I see you, Redox. Thanks for joining me on this chemical adventure."